In these examples, it says to sketch the region bound by the function and the x-axis on the given interval. Then evaluate the definite integral by using a geometric formula if necessary. Well, the question is, why are we sketching the region bound by the function and the x-axis? The definite integral, remember what it means. The definite integral on a to b an interval of f of x dx means the net area. The net area that is bound by the function and the x-axis. So that's why the directions are telling us to sketch that region. So first we have to decide what is the function. That's the integrand in here. Just in this case, f of x is 4 minus 2x. What is the interval? Those are from the limits of integration. The interval is 1 to 4. So if that's the region that we're sketching, we don't need any negative region. We can put our y-axis pretty close to the left on our little graph patch here, and our x-axis can go middle-ish. That'll work. And we know how to graph this. The y-intercept is positive 4, and the slope is negative 2, so we can get a good amount of points in here and connect the points to create our function right there. We only want the interval on 1 to 2, 3, 4. Just this interval right there. So bound by the function and the x-axis. So between the function and the x-axis, but starting at 1, that's going to be this region in here. Bound by the function and the x-axis, start ending at 4, that's then going to be this region in here. So we're shading between the function and the x-axis. That's the area that we're looking for. So remember that the definite integral means the net area. That means the area above the x-axis minus the area below the x-axis. So let's start with the area that's above. I'm going to call it a sub 1 for the first area that we're finding. This is a triangle, so our formula for a triangle, 1/2 times base times height. The base is 1 unit long, the height is 2 units long, so 1 times 2, that area is 1. The second region, we'll say that region there under the x-axis, also a triangle. So again, 1/2 base times height, and the base is 2 units long, the height is 4 units long. So that makes 4 units of area. So when we say the definite integral from 1 to 4 of 4 minus 2x with respect to x, that means the net area, or the area that's above the x-axis minus the area that's below the x-axis. So that will be for these values 1 minus 4 or negative 3. Does it make sense that it's negative? Well, definite integral, remember, doesn't mean the area, it means the net area, the area above minus the area below. Well, how much area is above compared to what's below? There's more area below, so this is telling us that there's more area that's on the negative side of the graph, below the x-axis. Let's take a look at the next example. Here the integrand is x cubed, so the function is x cubed. The interval, looking at our limits of integration, negative 2 to 2, so the interval is on negative 2 to 2. So we'll probably need to put our y-axis right in the middle to get the most use out of this graph patch, and same with the x-axis there. And we know when we plug in 2 we get 8, so we need to be able to see up high, up that high. So 1, 1, and then 2 goes all the way up there to 8. It's past where we have our graph, 3, 4, 5, 6, 7, 8. That's pretty high up there. And then negative 1, and negative 2, and 5, 1, 2, 3, 4, 5, 6, 7, 8. So that's down here. So that's pretty low. And connect. Oh, I did not put it at negative 1, did I? I put at negative 1, 0. Let's try that again. And there we go. That's gonna make more sense. When we connect it, and there's our cubic function. So let's sketch that area between -2 and +2. And remember that we're shading between the function and the x-axis. So here's the x-axis and here's the function. We want our shading to touch both of those, and we want to stop where x is 2. So creeping up there a little bit. Same thing here. Here's the x-axis, here's the function. So we want our shading to touch both the function and the x-axis. So we're shading, and it creeps into there a little bit. So what are these shapes? Kind of triangular, but not really. So we can't use a geometric formula to find that out exactly. But remembering that the definite integral is the net area, how much there is above minus how much there is below, knowing the symmetry of the y equals x cubed function, how much area is compared to what's above and below? Well, when it's an odd function, it's the exact same amount. So if we found this area on top, it would be the same as whatever the area is on the bottom. So they would subtract and make 0. So our definite integral from -2 to 2 of x cubed dx is 0, because the area above is the same as the area below. There is the same amount of area above and below the x-axis. And that's going to happen every time we have an odd function. So whenever we have an odd function, if our interval is equidistant from the origin, -2 to 2, -3 to 3, we're getting the same amount above and below, we are going to have a net area of 0. Let's take a look at next example. Using the function f defined for -2 to 3, notice where the x-axis is and the y-axis is. Just in case it's hard to tell, I will emphasize here there's the x-axis. There's the x-axis. See, it's as f, sorry, the y-axis, see it's as f of x, and the x-axis, see it's as x there. So we're only defined on this function from -2 to 3. So from the origin, there's the -2, and there's the 3. What is the value of the definite integral of the function on -2 to 3? So again, remembering this means the net area, we want to find the net area between the function and the x-axis. So just to do a quick shade, we are looking at between the function and the x-axis. So touching the x-axis, touching the function, there's our quick sketch of that area, shaded in. That's what we're looking at. So thinking that we want the net area, what's above minus what's below, we can find, well, this is a triangle, this is a trapezoid, do the area of the triangle, subtract the area of the trapezoid, sure. Or can we cut out some parts and make it a little bit easier? For example, I see a shape on top here that is a square and this tiny little triangle big, which is actually looking like the exact same shape as this, a square with a tiny little triangle. So those actually cancel each other out. I don't really have to find that area anymore of that trapezoid. So really, I actually only have to find this area in here. So let's call that area 1. Triangle, 1/2 times base times height, so that's 1/2, 2 units by 3 units. So that's a area of 3 units. And then this little region in here is one triangle, so let's call that area 2. Again, a triangle, 1/2 times base times height, so 1/2, the base is 1, the height is 2. That gives us an area of 1. Both of those areas being above the x-axis, all we have to do is add those together. So 3 plus 1 for a definite integral of 4, a net area of 4.